Okay, let's put everything together. So we have boxes and objects on inclines. We also have a pulley. So let's see if we can solve this one. So start by drawing our forces acting on our objects. So we have an 18 kilogram block on the left. So this one's 18 kilograms. And this other one over here is 15 kilograms. So we know that this block, it's going to have a force downwards, force of gravity, and it's going to have an X and Y component. It's also going to have a normal force going upwards. One thing to make this one a bit easier, I said there's no friction. But you can imagine if there was friction, what you'd first have to do is find out which of those two blocks is which one is creating greater driving force, either down the ramp to the right or down the ramp to the left. Because what we need to remember is that friction always opposes the direction of motion. So if I call this one FA1, if I draw this one FA2, if FA1 is bigger than FA2, we know this is going to go counterclockwise around the pulley. Therefore, the friction forces would be pointing more to the right direction. If FA2 is bigger than FA1, then we know it's going to go clockwise around the pulley. And the force of friction would be going in the left directions for the blocks. This one, no friction though, so we don't have to worry about that. So we have normal force going up. So F normal 1, F normal 2. We have FG1, FG2. I know this angle is 30 degrees. I know this angle is 65 degrees. So there is my picture. One more thing I need to include, because there is a pulley, there is some tension T pulling upwards in this direction, and some equal and opposite tension T for the other block. So I'm actually going to solve for what FA2 and FA1 are first. I say, what is FA1? FA1 is just FG1 and multiplied by sine 30 degrees. So FG1, that's the mass is 18 kilograms multiplied by 9.8 meters per second squared, multiplied by sine 30, we end up with 88.2. I'm going to round at the end, not right now. For FA2, we get FG2, sine 65 degrees. So 15 kilograms multiplied by 9.8 multiplied by sine 65. So 133.2 newtons. So what we can see from this is because FA2 is bigger, I know that this thing is going to rotate in the clockwise direction around that pulley. So I'm going to define that as my positive direction. So let's write a sum of the forces expression now. So I got sum of the forces, and so my direction is traveling that direction. Okay, that is my positive direction around, up the slope, around the pulley, that slope. So starting with FA2, we have FA2, that's we think of that as like our driving force, the thing that's getting this thing to go clockwise around the pulley. It's being opposed by some tension, but then we see there's another tension force in the positive direction, minus FA1. So those are the forces that are causing this thing to accelerate again. If there was friction involved, we'd see it'd be minus force of friction 2 minus force of friction 1, because both friction forces want to oppose the direction of motion. And because we're looking at the system, the tensions will cancel out. because there's no friction, the friction forces are going to cancel out. We are left with sum of the forces is equal to mass total times acceleration, which is just equal to FA2 minus FA1. So the whole system that's moving is both the combined mass 15 kilograms plus 18 kilograms. So all of that mass is being accelerated due to these two forces, which we found was 133.2 newtons minus 88.2 newtons. Let's get 133.2 minus 88.2, and we're going to divide that by 15 plus 18. So you're going to get an acceleration of A is equal to 1.3636 meters per second squared. Just round that to 1.4 meters per second squared. Next part is we want to find out what is the tension in the blocks. And so this one doesn't matter. We can look at the 18 kilogram block, or we can look at the 15 kilogram block. I'm just going to do one of them. You should, on your own, see if you can solve for the tension in the other one. Again, the values should be the same because Newton's third law states that for every action, there's an equal and opposite reaction. So whatever value you find for one t must equal the value for the other t as well. So I'm just going to draw it off to the right over here. So let's look at the 15 kilogram block. So there's this one. We know that one direction we have FA2, and it's being opposed by some tension T. And if there was friction, there would be a friction force right there as well, F friction 2. In this question, there is no friction. We also know that the system is accelerating now at A is equal to 1.4 meters per second squared. So if I do my net force equation, we find out that MA, this is block 2, so M2A is equal to FA2 minus tension minus force of friction 2. And that's going to equal to 0 though for this question. So our mass is 15 kilograms. We found our acceleration is 1.4 meters per second squared. FA2 was 133.2 newtons. And tension is what we are trying to solve for. So 15 multiplied by 1.4 minus 133.2. And we get tension comes out to be around 110 newtons. That is our final answer.